Ladies and gentlemen, this is our seminar number 11, and today we will solve some new examples. Yes, and some examples which you will see will be very known for you because you already see this example in the case of analysis of dependence or calculation of potential dependence. In case of analysis of the dependence of descriptive way only, yes, we calculated some measure of potential dependence between two or more variables, and today we will run appropriate statistical tests, yes, and we will evaluate if the zero hypothesis, some statement, yes, will be rejected on the particular level of significance or not. Yes? So from the descriptive way, we will move to mathematical statistics and hypothesis testing. So we will see some examples which you already seen, but in different way. So I think that this is clear, and I hope that we can start. We will start with hypothesis testing. I will solve this example. The brewery repaired quality of filling line for beer bottles. After repair, there were performed 21 measurements of bottles by random sample. The average volume of the filled bottle was 500.36 milliliters of beer with a standard deviation of 1.78 milliliters, and there is written very important sentence. It means that the values were calculated from the sample, yes, on the basis of formulas, formula for calculation of mean and sample standard deviation. We calculated these statistics. We assume the normal distribution. Verify at a significance level alpha equal to 0.05, it means 5% significance level, that the repair was successful. It means verify whether the line fills the bottles of beer by volume of 500 milliliters. In other words, we want to verify whether the calculated average is significantly different from the required value of 500 milliliters of beer. So, long story, yes? Okay. Write the null and alternative hypothesis, select appropriate test statistic and critical value. So, what is important here? You are probably owner of the brewery, yes? And you have filling line, and this filling line was broken, yes? And after repairment of this filling line, yes, you repair this filling line, you made, for example, n equal to, I don't know, 20,000 of bottles, yes? 20,000 of bottles of new beer, yes? And you went to the warehouse, yes? And you selected 21 bottles. So this is your random sample from population of beer bottles in your brewery, yes? So you have observation, yes? You have observation x1, x2, x3, yes? Until x21, yes? 21 bottles, your random selection, and you measured, yes, for example, the volume in this bottle, for example, 501 milliliter of beer, yes? In the Czech Republic, we have standard 1/2 of liter, yes? For example, in France, Belgium, Netherlands, the standard is 330 milliliters, but in Czech Republic we have 1/2 of liter, yes. So the measurement here, for example, 499, yes, but we don't know this data set, yes, we don't know these data, but you know that somebody calculated for you the mean, yes, the average, 500.36 milliliters of beer. Yeah? So this is your first sample statistic, and the other one, standard deviation, which was calculated like square root from the variance, yes, and variance is summation through all e xe minus this sample mean squared divided by n minus 1. It's very important that this is calculated sample standard deviation with n minus 1 in the denominator. So who calculates the standard deviation used here 21 minus 1 in denominator, yes? And this standard deviation was calculated according to the story written here in this example, 1.78 milliliters, yes? 1.78 milliliters. Okay, so you have here sample standard deviation, and here you have sample mean, yes, sample statistics. Okay, so we would like to verify at the significance level alpha 5%, the repair was successful. We would like to verify whether the line fills the bottles of beers by volume of 500 milliliters. We will write a null and alternative hypothesis. Null hypothesis, yes, claims something. In the case of null hypothesis, yes, every time is equal sign. In this situation, mu is equal to mu 0. In our situation, we can write here that mu, the mean, the average, is equal to 1/2 of liter of beer, 500 milliliters of beer. Yes, so this is our zero hypothesis. And according to your formulas, you can see that we have 3 types of alternatives. H1, yes, mu is higher than mu 0. Mu is smaller than mu 0, and mu is not equal to mu 0, yes. If you fill the bottles by more volume, yes, it will be wrong for you, yes, for the owner of the brewery. If you fill the bottles less than 1/2 of liter, your customers will not be satisfied, yes, because they will get less beer in the bottle. So only one good alternative here, yes, logically, is this third type, yes. It must be equal to 500, yes. Everything else is wrong, higher or smaller. So I will select this alternative hypothesis. What it means? It means mu is not equal to 500 milliliters of beer. Yes? So this is your null and alternative hypothesis. And now we must select appropriate test statistic and critical value. I must use formulas and find here appropriate test criterion. What is important here? I don't know the variance or standard deviation which is connected with population of these bottles. Yes, so this variance, this sigma, is unknown, and I have only calculated value of the standard deviation. It means s squared calculated value of the variance. Because of this, I must use the test statistic for sigma square unknown. Yes, sigma squared unknown. And for this situation is designed student t-test. Student t-statistic is equal to x with stripe minus mu 0 divided by calculated standard deviation times square root from n. Because we know everything, yes, we can use values and calculate this test statistics. So, in our situation, calculated mean, the sample mean, 500.36 milliliters of beer, yes, minus 500. 500 is the value which is written here, mu 0, yes? Can you see this mu 0 is a statement from the zero hypothesis, yes? So difference, 500.36 minus 500 divided by calculated standard deviation 1.78 milliliters of beer times square root from n is my sample size, 21 bottles, yes? So this is the test statistic, and now I will write here t is equal to, okay, so there is in denominator 0.36 divided by denominator 1.78 times square root from 21 bottles, and the result is 0.927. Okay, so this is value of t-test, this is value of student t-statistic. Okay, and in your formulas, you can find that you have written three versions of rejection regions, yes, three versions. It depends on the type of alternative hypothesis. If you select this first type of alternative hypothesis, you must select the first row of rejection region. If you select this second type, yes, of alternative, you must select the second row. And because we selected this third type, we must check the third type of the rejection region. So please make ready your tables for the situation sigma squared unknown, population mean, expected value, normal distribution in population. And the rejection region is here, W alpha. W alpha is equal to, for the situation of student t-test, if absolute value of your t-statistic is higher or equal to critical quantile t 1 minus alpha divided by 2, we entered to the rejection region, and it's necessary to reject zero hypothesis. We must use our alpha significance level. Alpha is 0.05. Yes, this alpha was written at the beginning of our example. Yes, verify at alpha 5% significance level that the repair was successful. So significance level alpha is 5%. Therefore, this quantile, this critical quantile will be. I will use another paper. T 1 minus 0.05 divided by 2. There is 2.5%. So 100 minus 2.5% is 97.5%, 0.975. 97.5% quantile of the student T distribution with degrees of freedom ni. This is small Greek letter ni, which is calculated like n minus 1. In our situation, 21 bottles minus 1 is equal to 20. 20 degrees of freedom. 20 degrees of freedom. So we must find quantile T 0.975, 97.5% quantile of the student T distribution with 20 degrees of freedom. I will check the statistical tables where I have quantiles of the students distribution TP. P-value 0.975 is in the middle and 20 degrees of freedom is here. This is not V. This is small Greek letter ni. Yes? So 20 degrees of freedom and the value of this quantile is 2.086. So this is equal to 2.086. Okay, and now there is a question. If absolute value of this, if absolute value 0.927, if this is higher or equal to 2.086, we entered to the rejection region and we must reject zero hypothesis at a 5% significance level. This is not true, yes? So we will not enter to the rejection region, yes? The T statistic is element of region of acceptance, yes? It means H0 is not rejected. H0 is not rejected at 5% significance level. Yes, zero hypothesis is not rejected at a 5% significance level. What it means? It means that the repair of the filling line was successful. It means that the average is equal to 1/2 of liter of beer. Yes, we write a null alternative hypothesis. We selected appropriate T-test statistic, and T critical value from students T quantiles. H0 is not rejected according to our data set. Yes, and the mu is equal to 1/2 of liter of beer. How the process and the result change if the standard deviation of the filling volume is known? It means that this is not the value calculated from the sample and its value is 0.78. Now, different situation. Can you see this population of beer bottles in the warehouse? Now, I know sigma equal to 0.78, and this standard deviation is connected with the population and not with the sample. Yes, I don't have this sample standard deviation. I have deviation which is connected with the population. So because now sigma squared is known, yes, sigma squared is known, we can use test statistic with standard normal distribution Z Yes, and there is written the formula x with stripe minus mu 0 divided by sigma times square root from n. Again, we know everything, so we can use the values which we know, yes. Calculated mean, yes, calculated mean on the basis of the sample, yes, you know this mean, it's written here. So again, 500.36 minus 500, the statement from the zero hypothesis, yes? This is divided by known standard deviation 0.78, yes? Standard deviation, sigma, without squares, yes? Times square root from 21 bottles. Okay, so I will use the calculator and I will calculate the numerator 0.36 divided by 0.78 times square root from 21 bottles, and the result is 2.115. Yes, this is your test statistic, your test criterion, yes, test statistic or test criterion, test statistic I can write here, yes. Okay, so we have zero and alternative hypothesis, the same, yes. H0 claims that mu is equal to 500 milliliters. H1 claims that mu is not equal to 500 milliliters of beer, yes? The third type of alternative. So please check your formulas, and there you can find three types, yes, of rejection regions. And we will rewrite this one. W alpha is equal to, for the situation of Z statistic is valid if absolute value of Z is higher or equal to quantile Z 1 minus alpha divided by 2 from the tables, yes, we entered to the rejection region and we must reject the zero hypothesis. Okay, again, we are using alpha equal to 0.05. We are using 5% significance level. So it's necessary to determine this quantile, yes? Okay, so we know that we must find Z 0.975, 97.5% quantile of the standard normal distribution. So there you have your tables. P-value 0.975 is here, and there is well-known quantile 1.96. Yes, so 1.96. And now the very important question. If absolute value of Z 2.115, yes, if absolute value of this test statistic is higher or equal to 1.96, we enter to the rejection region. Yes, this is true. It means that we entered to W alpha. Yes, we entered to the W alpha. It means H0 is rejected at the 5% significance level. Yes, at the 5% significance level, zero hypothesis is rejected, and it means that the mu is not equal to 500 milliliters of beer. Yes, we rejected this hypothesis. This hypothesis claiming that mu is equal to 500 milliliters is rejected. No, it is not equal to 500 milliliters of beer, so the reparation of the filling line was not successful. We will continue with this example. In the Czech Republic, yes, the limit for election for each political party into the House of Commons is set at 5%. Yes, if you want to enter with your political party to the House of Commons, yes, you need to reach in the elections at least at 5%, yes, at least 5%. There was a survey carried out, very small survey in the population, yes, where from 350 respondents, 28 people voted the monitored party. And there is a question, can we expect that this party will get into the House of Commons in elections with significance level of 1%? So, what is important here? Probably this survey, yes, is connected with the population of the Czech Republic. I don't know now how many exactly inhabitants, yes, 10,517,838, yes, probably this is the population of the Czech Republic, yes, and there was only a small survey, yes, only small survey. We asked n equal to 350 persons, yes, this is the survey random selection, and we asked these respondents, yes, about who will be the candidate, a favorite, yes, in the election, and small m of people said that I would like to vote this monitored political party, yes, 28 of them. So, according to this, we can calculate the proportion of potential voters in this sample, yes, the sample proportion of persons who would like to vote this political party. How can you calculate this proportion? Like m divided by n. Yes, in our situation, 28 persons, yes, who would like to vote this political party divided by 350 respondents. Yes. Okay, so 28 divided by 350, and the result is 0.08. Okay, now there is a question. There was written that limit, yes, for election for each political party in the Czech Republic is set at 5%. You have here a survey, yes, one small survey through the Czech Republic, and the result is, yes, that 8%, yes, of persons in your selection would like to vote your political party or this political party, yes. Why? We must continue with some hypothesis testing, yes. Why we don't say to the leader of this political party, hey, we will probably reach 8%, you can be happy, yes. We must test, yes, we must test at 0.01, 1% significance level, yes, that this is a system, yes, this is a systematic value, that this is not a random outlier, yes. So we must test zero hypothesis. We must test zero hypothesis, and you know that zero hypothesis, everything climbs something, yes. In our situation, we can say that P is equal to P0. In our situation, that the proportion of voters, yes, will be equal to this limit, 5%, yes, the minimum limit in the Czech Republic, 0.05. And you will be happy, or your boss, the leader of this political party, will be happy if you reject this zero hypothesis against the alternative A, H1, that the proportion of voters is higher than value P0, that proportion of voters is higher than 0.05, yes? Zero hypothesis, everything climbs something, yes? There must be equal sign every time. But our wish is at 1% significance level, reject this zero hypothesis and say that the proportion of voters in all Czech Republic will be higher than 5% and the monitored party will enter to the House of Commons. Yes? But we don't know this. Yes? We must calculate it. So we know what is P0 in our situation. We have zero and alternative hypothesis. And please check your formulas. And find here population proportion large sample. We have sample n higher than 30, yes, because we have 350 respondents. So this is large sample. Test statistic has standard normal distribution Z, and this test statistic is equal. In denominator, there is sample proportion minus P0 divided by square root, and there is P0 times 1 minus P0 divided by n. Okay, we know practically everything, so we can calculate the value of statistic Z, yes? The value of this statistic Z will be calculated here. So, Z is equal to numerator. Your calculated proportion of voters, 8%, 0.08, minus the value from zero hypothesis, 0.05, divided by, and there is square root P0, 0.05 times 1 minus 0.05, close the parenthesis, yes? And this is divided by n, number of respondents, 350 respondents, yes? So now you can use calculator and calculate the value of statistic Z. So 1 minus 0.05 times 0.05 divided by 350, yes, square root from this value, and denominator is 0.03 divided by this result. So value of Z is 2.575575. This is your test statistic. So this is the value of Z. Yes. And the next is still the same. Next is still the same, like in the situation of each hypothesis testing. So we must find appropriate rejection region. So please check your formulas. Find here population proportion, large sample, rejection regions. Yes, because we selected first type of alternative hypothesis. I will rewrite here on the paper the first type, yes, of the rejection region. You can check me. There is written W alpha is equal to, for the situation of statistic Z, yes, is valid. If statistic Z is higher or equal to quantile Z, 1 minus alpha percent, 1 minus alpha percent quantile of the standard normal distribution. We entered to the rejection region and we can reject zero hypothesis. Yes, and your boss will be probably happy. So, our statistic Z is 2.575. Can you see this is one side alternative, therefore there is not absolute value, yes? If this value is higher or equal to, we are using 0.01, we are using 1% alpha, 1% significance level, so we must find 99% quantile of the standard normal distribution. So please check the tables, statistical tables. There is p-value 0.99, 2.326. 2.326 is critical value. And there is a question if this inequality is true. Yes. This inequality is true, so this test statistic is element of W alpha rejection region, so A0 is rejected at the 1% significance level. A0 is rejected at the 1% significance level, and it means that you can expect that this party will get into the House of Commons in election with this significance level. Yes, we can expect that this party will be probably voted to the House of Commons. A0 was rejected, and your boss, the leader of this political party, will be probably happy. I will continue with this example. During repeated rolling of the fair dice, the cube, yes, there were observed from 60 rolls those results, yes. There we have value xj, 6 possible values, and empirical absolute frequencies nj as follows, yes. You can imagine the dice, yes. There is classical fair dice, yes. There you have position 6, yes, and you repeat it n equal to 60 times, yes, 60 times these results, yes. So there you have empirical absolute frequencies, summation of these frequencies is equal to 60, so there is summation. Verify on 1% level of significance that the fair dice is all right. It means that it has its centroid in the geometrical center. What it means, yes, you have here value 1, 2, 3, 4, 5, 6, yes, and you 60 times, yes, repeated rolling. So you have here empirical absolute frequency. But if this dice will be alright, yes, you know that you have the same probability for each value on this dice, yes, and because we repeated the rolling 60 times, I can expect nj with stripe, for example, yes, I can expect that I will see 10 times value 1, 10 times value 2, 10 times value 3, 10 times value 4, 10 times value 5, and 10 times value 6, yes? So again 60 times something, but distributed in this way, yes? Instead of this, I've seen the value 1 only 9 times, value 2 only 8 times, yes, value 4 12 times, etc. So the distribution is a little bit different. So I would like to test the hypothesis H0, which is written in your formulas. You can find here chi-square goodness of fit test. And there is written Pj is equal to P0j. What it means? It means empirical relative frequencies are equal to theoretical relative frequencies, yes? Or maybe Mr. Hellman using instead of theoretical expected, yes? Expected relative frequencies, yes? So this is zero hypothesis. We can also, yes, write here instead of relative frequencies, yes, you can imagine that there is written Nj is equal to Nj with stripe, yes? Why? Because I have here empirical absolute frequencies and expected absolute frequencies. And this test is based on this, that this value is equal to this value, and this value is equal to this value. This value is equal to this value. These values, yes, are equal to these values. Chi-square goodness of fit. Goodness of fit test, yes? It means that empirical frequencies are equal to expected frequencies, yes? And alternative hypothesis, H1, climbs non-H0. At least in one situation, at least at one position, it is not true, yes? It's possible to calculate value of G. Test statistic, yes, is G, and we can calculate the value of this G. In your formulas, you can find summation, yes, it's summation through all J, and there we have in nominator Nj minus N times P0j. This is in squares, and this is divided by N times P0j. Yes? What is it? P0j. P0j is here in this relative, yes, in this relative frequency, relative statement of the zero hypothesis. I can calculate P0j here. P0j here. How? In all situation, this value will be 10 divided by 60, yes? Relative frequency, 10 divided by 60, yes? 10 divided by 60, 10 divided by 60, 10 divided by 60, 10 divided by 60, yes? This is recalculated from absolute frequency to relative frequency. So, what is written here in this zero hypothesis? There is 6 times write something because you have here J index, yes? In the zero hypothesis, there is written that 9 divided by 60 is equal to 10 divided by 60, yes? Can you see this value 9? And you can continue. And through all J, yes? 8 divided by 60 is equal to 10 divided by 60. And you can continue, and the last is 11 divided by 60 is equal to 10 divided by 60. So this is the zero hypothesis through all j, yes, through all j. So now it's clear what is written here. If you multiply, yes, 10 divided by 60 by 60, number of observation, can you see 60 times 10 divided by 60? Result is 10. So now it's very, very easy. Yes, it's very, very easy. Why? Statistic G. Yes, check this. Nj, 9 minus n times p0j, 10. This must be in squares divided by 10. This is the first part, yes? And it's through all j, so you can continue. Plus, second row, yes, will be 8, and after 11, and after 12, and after 9, and after 11, yes? So, 8 minus 10. This is in squares divided by 10. Plus 11 minus 10, it is in squares divided by 10, plus, and you can continue, yes, 12. 12 minus 10, it is in squares divided by 10, plus 9 minus 10, it is in squares divided by 10, plus the last value 11, yes, 11 minus 10, it is in squares divided by 10. Okay, so that's all, and now you must solve this, yes, equal sign. So, 1 square divided by 10 is 0.1, plus 2 squared is 4 divided by 10, 0.4. There will be again 0.1, plus there will be 0.4, plus there will be 0.1 and there will be 0.1, so plus 0.1 plus 0.1 equal sign. 1 and 4 is 5, 6, 1.0, 1.2. 1.2 is the result, and this is value of G. Value of statistic G, the test statistic. Okay, now in your formulas, you can find rejection region, yes? There is only one rejection region, W alpha, and this rejection region is as follows. For the statistic G, yes, is valid. If G is higher or equal to critical quantile chi square 1 minus alpha %, we entered to the rejection region and we must reject the zero hypothesis. What was written here? Verify on 1% level of significance. So alpha, it means that alpha is equal to 0.01, 1% significance level. So we must find, yes, we must find chi square quantile 1 minus 1%, 0.99. We must find the 99% quantile of the chi square distribution with degrees of freedom, ni, and this degrees of freedom is calculated like k minus 1. If you want to know what is k, in our situation is number of rows. Yes, number of rows in our table. So you have here 6 sides of the fair dice, 6 possible values. Yes, so there will be 6 minus 1, and this is equal to 5. So you are searching this quantile, 99% quantile of the chi-square distribution with 5 degrees of freedom. So check your tables and find something where is written chi-squared. Yes, quantiles of chi-square distribution. Find this table with this small Greek letter chi. Yes. And degrees of freedom, ni, is written here, and p-value is p-value, yes? So please check this column in the middle, yes? 0.99, and there you can see 5 degrees of freedom, so 15.1. Yes, find the critical quantile, 15.1. So this is critical value. Okay, so now we can decide. Our G is equal to 1.2. Yes. If this inequality is valid, we enter to the rejection region and we must reject zero hypothesis. It's not true. Yes. 1.2 is not higher or equal to 15.1, so A0 is not rejected. Yes, is not rejected at alpha equal to 0.01, 1% significance level. Yes, so what it means? It means that empirical frequencies are equal to expected theoretical frequencies. It means that the fair dice is all right. It means that the dice has its centroid in the geometrical center. Yes, these values are equal to these values. Yes, so this was chi-square goodness of fit test. Yes, chi-square goodness of fit test. And now you can imagine, yes, that you take the chewing gum and you will put the chewing gum, for example, on this side of the dice. Yes, opposite value 6, yes, is position 1. Yes, and you will use the chewing gum and you will put here the chewing gum. Yes, so this side will be heavy and you will see more times position 6. Yes, and the position 1 is chewing gum, you will see more times value 6. So you can imagine that instead of value 9 here, you will see value 1 only 1 times, and instead of value 11 here, you will see 8 more times, 19 times value 6. Yes, you are cheating. You have chewing gum on the fair dice. Now it's not fair dice, it's just dice. Yes, and you will see more times this value 6. So where will be the difference? Here, yes, in the case of this calculation, there will be, instead of 9, will be 1. 1 minus 10, yes, and there, instead of 11, will be 19, yes, and what is here? 1 minus 10 is minus 9. Minus 9 squared, yes? 9 squared is 81. 81 divided by 10 is 8.1. So here, instead of this value, is 8.1. 0.1, and there is 19 minus 10 is 9, squared is 81, divided by 10 is again 8.1. So there, instead of 0, is again 8, yes? Okay, now statistic G is different, so you can use calculator. 8.1 plus 0.4 plus 0.1 plus 0.4 plus 0.1 plus 8.1, 17.2, yes? 17.2 will be now the value of the statistic G, yes? And if this G is higher or equal to critical quantile 15.1, yes, it means that we will enter to rejection region W alpha, and H0 will be rejected. Yes, H0 will be rejected at alpha 0.01, 1% significance level. So if you use the chewing gum, yes, and from the fair dice you will make the dice, yes, and you are cheating, you will receive more value 6 instead of 1, yes, your G statistic will be higher than critical value, and you will have to reject zero hypothesis, yes. But if the situation will be according to original dataset, everything is all right, and the dice is all right. We will continue with this example. You remember this, yes? There were surveyed 93 patients suffering by a disease, whether they were vaccinated and what is the development of the disease. So we have here a table, and in your papers, in your Microsoft Excel sheet, you have only this table with these values, yeah? The printed values. So that is the question. Does the development of the disease depend on whether the patient was vaccinated? Today we will test on alpha 5% level of significance, yes, if there is the relation. If you remember, many weeks ago, yes, we had this table, and according to statistic G, value of the statistic G, we wanted to calculate and measure the strength, yes, of the dependence according to Pearson coefficient of contingency C and the Kramer coefficient of contingency V. So, what is necessary to know? If you don't know how to solve this, yes, please repeat my seminar a few weeks ago. I don't know the number, but analysis of dependence in descriptive way. Yes, we have here contingency table, a table with empirical values sorted, yes, to the cells. I have here marginal frequencies, N-E dot and N.J, yes, in total 93 patients. How can you calculate this? It's a summation of values in rows and summation of values in columns, yes? And according to this formula, you are able, according to this formula with stripe, yes, you are able to recalculate these empirical frequencies to expected frequencies, theoretical frequencies, NEJ with stripe, yes? Patient vaccinated, yes and no, mild and hard development of the disease. And according to empirical and expected values, we calculated the value of G. Yes, we calculated the value of G. And on this page, yes, you can find the steps, yes, which you already know. Yes, we already solved this according to formulas written in your formula sheet. There is a sentence. There are steps. Yes, with 4 partial results. 4 partial results here, and value of G is here. And according to value of G, 22.28, we calculated C value and V value. Yes, so you already know this. But now we will use this example one more time, and we will run the hypothesis test. Run the hypothesis test. H0. What is written in your formulas? H0. Variables are independent. Yes, variables are independent. This is the zero hypothesis. Alternative 1, non-H0. There is a dependence, yes? So we will use alpha equal to 0.05, 5% significance level, and we will test this hypothesis. Okay, what is necessary for us? For us, it's necessary the value of G, because the value of G is now the test statistic. Yes, test statistic. And this test statistic G is equal to 22.28 will be compared with critical value. Please check your formulas and find here a rejection region. This G can be element either of region of acceptance or rejection region, yes? And the rejection region, W alpha, is equal to, for the situation of statistic G is valid if G is higher or equal to critical quantile chi squared 1 minus alpha %, it's necessary to reject zero hypothesis. Okay, so we are using 5% significance level. So it's necessary to check the statistical tables and find 1 minus 0.05 equal to 0.95. Find 95% quantile of the chi-square distribution with degrees of freedom ni, and ni is calculated number of rows minus 1 times number of columns minus 1. In our situation, 2 rows minus 1 times 2 columns minus 1. 1 times 1 is equal to 1 with 1 degree of freedom. So please check your statistical tables and find here this quantile, 95% quantile of the, there is written, yes, distribution chi squared, quantiles of distribution chi squared, and there you have p values, yes, p values in the top row, so 95%. And this is small Greek letter ni 1. Yeah? So please find in your tables value 3.84. 3.84, and this is chi squared. Yes, chi squared. Okay, so 3.84. Okay, and now you are able to decide. If G, 22.28, is higher than 3.84, We entered to the rejection region, and the zero hypothesis must be rejected at the 5% significance level. It's true. So this zero hypothesis is rejected at the 5% level of significance. It means variables are dependent. Yes, variables are dependent. What it means? It means that there is a relation. There is a statistical relationship between the development of the disease and if the patient was vaccinated against this disease. Yes? And if there is a relation characterized by the intensity of the existing dependency, we already did this. Yes? Now we know that there is a dependence, and according to your formulas, we already calculated Pearson coefficient of contingency C and Kramer coefficient of contingency V. So if you don't remember the results, yes, of Pearson C and Kramer V, you can check previous video seminars. We will continue the same example, the same type, but different size. You already remember this example, yes? There was observed the relation between the level of the alcohol in blood, low, middle and high, and the speed of the reaction in car during driving, good and bad, by 100 randomly selected people. And there is a question, is there a relation? Yes, do you remember this question? We calculated the value of statistic G. And according to this G statistic, we characterize the tightness, the intensity of dependency according to Pearson coefficient C and Kramer coefficient V. But now, we will run the hypothesis test, statistical hypothesis test. We will use alpha 5% level of significance, and we will test if there is a relation on this significance level. Yeah, so again, we will run the statistical hypothesis test. So there you have empirical data, yes? In your sheet you have only these values, which I have here written in green color, yes? So if you don't know how to calculate the marginal frequencies NE dot and N dot J, yes, it's necessary to study my seminar many weeks ago, yes, because we already knew this. Okay, so you have marginal frequencies. According to marginal frequencies NE dot and N dot J, and according to this formula, yes, which is written here, it's necessary to calculate the table with expected frequencies, theoretical frequencies, yes, theoretical frequencies, how the frequencies will look like if the table will be independent, if there will not be a dependence between the speed of the reaction and the level of alcohol in blood, yes? And according to empirical frequencies in this table and theoretical expected frequencies in this table, we already, many weeks ago, calculated the value of G, yes, the value of statistic G. So there you have written the partial steps, there you have written the partial results, and our statistic G, which was used for the calculation of C value and V value, yes, Pearson C and Kramer V, yes, there is this statistic G. And now I will use a new paper, yes, and I will set 0 and alternative hypothesis. Zero hypothesis and alternative hypothesis. What is zero hypothesis? Zero hypothesis, variables are independent. Yes, variables are independent. Alternative one, non-H0. There is a dependence, yes? You remember that we calculated large values of Pearson statistic C and Kramer statistic V, yes, I don't know, 0.6, 0.7, yes? So there is probably a dependence, but we would like to test this on alpha equal to 0.05, 5% significance level. So what is necessary for us? It's necessary to know the value of G, which was 36.39. And after, it's necessary to know how looks the rejection region, W alpha. Rejection region is defined as follows. For the statistic G is valid if G is higher or equal to critical quantile chi squared 1 minus alpha % with degrees of freedom ni, and ni is equal to rows minus 1 times columns minus 1. Yes, number of rows. How many rows in our table we have? We have 3 rows and 2 columns. Yes, so there is 3 minus 1 times 2 minus 1. 2 times 1 is equal to 2. 2 degrees of freedom. And this quantile, if we use 5% significance level, this is quantile chi squared 0.95. 95% quantile of the chi square distribution. Again, so please check this table, quantiles of distribution chi squared, with high p-values here, yes, from 0.90 to 0.9995. And 95% quantiles are here in the second column, and degrees of freedom 2 is here. So the critical value is 5.99. Yes, can you see this value? 5.99. Okay, and now the decision is very easy. If this statistic G, value of statistic G is higher than critical quantile from chi square distribution, we must reject zero hypothesis. So H0 is rejected. H0 is rejected at the alpha equal to 0.05 at 5% significance level. What it means if H0 is rejected? Rejected is variants are independent, so variables are independent, so this is rejected. Variables are dependent, yes. According to our data set, variables are dependent, yes, it depends on the speed of the reaction, yes, it depends the speed of the reaction in car on the level of alcohol in blood. So because there is a dependence, you know that in many countries in the world it's forbidden to drink before driving, yes, so there is a relation, and there is a duty, there is a sentence, if there is a relation characterized by the intensity of the existing dependency. You remember that we already calculated many weeks ago value of Pearson coefficient C and Kramer coefficient V. Yes, so you can practice, you can calculate it, or you can find a video where is calculated Pearson C and Kramer V. Another example, which you probably remember. We observed 12 students, how many points they got from the final test, the values from 0 to 60. And we know that 4 of these students were always attended the classes of one of the 3 teachers, Mr. McDonald, Mr. King, and Mr. Benz. And there is a question, has the person of the teacher the influence on the number of achieved points from the final test? Now we will use the hypothesis testing. We will test on the alpha 5% level of significance. So, do you remember when we calculated effect size? Do you remember this? We had to sort this table. Yes, we had values x, e, j. Yes, and there we had values for Mr. McDonald, 53, 47, 55, and 50. Yes, and after the values for Mr. King, 42, 48, 48, and 50. Yes, and after we had here the values for Mr. Benz. And for the calculation of effect size, we had to calculate sum of squares. Yes. So, do you remember SS, sum of squares treatment? Yes. And sum of squares error. Sum of squares error. Yes. Treatment sum of squares and error sum of squares. And of course, do you remember that sum of squares total is equal to sum of squares treatment plus sum of squares error? Yes? Am I right? Do you remember this? Okay. So now, we will not calculate effect size, but we will remember the results of these sum of squares, yes, and we will use the hypothesis test for ANOVA, yes, which you have written in your formula sheet, and there is written 0 hypothesis, mu1 is equal to mu2 is equal to mu3. Equality of 3 means, in our situation, average number of points, yes, which you receive from Mr. McDonald, is equal to mu, average number of points, which you can receive from Mr. King, yes, and this is equal to mu, average number of points, which you can receive from Mr. Benz. Yes? Okay, so equality of at least 3 different means. This is ANOVA, analysis of variance method. This zero hypothesis means independence. Yes, independence. There is independence if you have the first teacher or second teacher or third teacher. Equality of true means independence. Alternative hypothesis is dependence. Yes, dependence. And we can also write non-H0. Yes, at least in one case. at least in one situation, at least in the case of one mean, yes, there is statistically significantly different, yes, statistical significant different of mean, at least in one case. Okay, so zero hypothesis, independence, equality of at least three means, at least three means, and dependence is alternative hypothesis H1. If you don't remember these values, you can watch the video seminar a few weeks ago. Yes, we calculated sum of squares treatment SSTR equal to 181.17. Yes, you can see there is output from Microsoft Excel. I calculated now. This between groups means TR, like treatment or theoretical. Yes, treatment, and SS means sum of squares. Within group means error. Yes, error. So sum of squares error is equal to 107.5. Yes, and total SS total sum of squares is equal to 288.67. Okay, so there you have three sum of squares. Yes, our zero hypothesis is independence, alternative one is dependence. We need to calculate Fisher F statistic, which is here. For the hypothesis test, according to your formulas, it's necessary to calculate this Fisher F statistic. And if you check your formulas, you can see that Fisher F statistic is calculated like sum of squares TR, treatment, yes. We already calculated treatment sum of squares, yes, divided by k minus 1. And this is divided by sum of squares error divided by n minus k. Yes. Okay, so we know everything. Yes, so we can calculate this. Treatment sum of squares 181.17. Yes, we calculated this value by formulas. Yes, divided by, what is it, k? In our situation, number of teachers, number of groups. Yes, you can see we have here three groups: Mr. McDonald, Mr. King, and Mr. Ben. So three teachers, three groups, minus 1, yes, and this is divided by error sum of squares, so 107.5 divided by what is here, n minus k, number of observation. Yes, there was written that we have 12 students. So number of observation is 12. 12 students minus 3 teachers. Yeah, so there is value 12 minus 3. Okay, and that's all. And the result will be Fisher F statistic. F is equal to, I will use calculator. And that is 181.17 divided by 2, yes, and this is divided by 107.5 divided by 9, and the total result is 7.58. 7.58. So this is the value of the Fisher F statistic. And if you check this table, which is calculated in Microsoft Excel, you can find here this Fisher F statistic, Fisher F value. Yes, okay, so 7.58, I calculate this correctly. Okay, so what else is written in your formulas? You have written zero and alternative hypothesis. You have written how to calculate Fisher F statistic. And after, you have written the rejection region. Why? Because F statistic can be element either of region of acceptance or rejection region. Yes? And the rejection region, W alpha, is equal to, for the situation of F statistic is valid, if F is higher or equal to critical quantile F 1 minus alpha percent with degrees of freedom Ni1 and Ni2. Ni1 is equal to K minus 1 and Ni2 is equal to N minus K. This Fisher-Snedeker distribution using 2 degrees of freedom, Ni1 and Ni2, yes? So in this situation, 3 minus 1 is 2, and in this situation, 12 minus 3 is equal to 9. 2 and 9 degrees of freedom, and there was written here that we must test on alpha 5% level of significance. So we must find F critical value 0.95. 95% quantile of the Fisher F distribution with 2 and 9 degrees of freedom. So please find the table where is written this F 0.95. There is written quantiles of F 0.95 distribution F 0.95. Yes, quantiles of Fisher-Snedeker distribution, and there I have Ni1 in columns and Ni2 in rows, yes? And you know that you must find 2 and 9. So, second column, yes? There must be F 0.95, yes? You have a lot of these pages. Ni1, 2, and Ni2, 9. So please find value 4.257. 4.257. This is critical value. Yes, and your test statistic F is 7.58. If this is higher or equal to 4.257, yes, it's true. Yes, this is true. So we entered to the rejection region. Because this is valid. And zero hypothesis will be rejected. So this zero hypothesis is rejected at a 5% significance level. Yes, at alpha equal to 0.05, H0 is rejected. Yes, at 5% significance level, we rejected zero hypothesis, which claimed that mu, yes, the average from Mr. McDonald is equal to average of Mr. King and is equal to average of Mr. Benz. Yes, so independence is rejected. So what it means? It means that it depends. Yes, it depends on the teacher how many points, yes, you receive from the final test. There is a dependence. And because there is a dependence, many weeks ago, we calculated effect size. Yes, effect size is a statistic from range 0 and 1. I don't remember the value of effect size, but you can calculate it, yes? But now, according to hypothesis test, yes, we rejected zero hypothesis, we rejected independence, there is statistically significant dependence. Okay, ladies and gentlemen, so this is the end of seminar number 11, and you can expect that this is not the end of hypothesis testing, yes? We have some tests in front of us, hypothesis tests, yes? So next week we will continue with hypothesis testing, and I will add for you something new, something different topic, yes? So I hope that I will see you next week. This is the end for today. Have a nice day, have a nice rest of the day, and bye-bye.